Hello. I'm going to review the problems for the exam and go over the explanations. So this is problem number 1. Consider a gusset plate of a bridge truss shown in the figure, and you have the magnitudes of forces 1, 2, 3, and 4, but what the question was on force 2. So this is a very straightforward problem where you have the force in X and in Y, and as I mentioned, F2, the magnitude is 4.8 kilonewtons, which is given here. So the component of the force in X would be 3/5 F2, or 3/5 4.8, which is 2.88 kilonewtons. And then of course this is to the right, or you put a positive. And then F to Y would be 4/5 F2, or 4/5 4.8 kilonewtons, which is 3.84 kilonewtons, and this would be up, or in this case positive. So that's a straightforward problem. This is problem number 2. If the magnitude of the resultant force, so I'm giving you the magnitude of the resultant force, is 550 newtons, and it says it's directed along the positive y-axis. So I'm telling you that this is 550 newtons, and this is the resultant force. So this is the magnitude, and if we use it in terms of vectors, then what we have, the resultant force in Y is 550 newtons, and then this would be J, and it's positive. So this is here the vector. So here we have the magnitude and the vector. So what you have to calculate here is the force F if the direction here is 47 degrees. So the sum of the forces in X equals 0, and the sum of the forces in X, in this case we're not looking at the equilibrium forces, but would be the resultant force in X. Okay, and this is 0 because it all goes in the Y direction, and the sum of the forces in Y would be the resultant force in Y, which is 550, and then we have newtons, of course. So if I do sum of the forces in Y, what I have is negative, and going up is positive, negative 700 sine of 15 degrees plus F sine of 47 degrees, and this will equal 550 newtons. So if we solve this expression, the force here is going to be 1,000 newtons. So this other problem is just to determine the coordinate direction angle of the force, and it's giving us some information. What I did here was just provided you with the box. I think that box is very important to make sure that you understand what are the angles that we're looking at. Okay, so let me look at my notes here, make sure I have all the numbers correctly. So anyway, we have the force here, it's 75 pounds, and this 75 pounds is in a 3D component, so you need to make sure that you know what angles we're referring to here. So this here would be the component of the force in Z. This here would be the component of the force in X. And then this here would be the component of the force in Y.